Welcome to a lesson with Dr. Powell. Let's talk about breadth first search and depth first search. So you can search in a graph by breadth or by depth. So depth means that you have an edge and then you're trying to label or traverse or look at each one of the edges as you go through the graph. And if you look at this, what you could do for depth is you traverse an edge, then you go to an edge that comes from there. And then you go for an edge that comes from there, and you so forth until you can't go any further. And then you backtrack, and maybe at this vertex there's another place. So you keep going down there until you can't go any further. Then you come back to maybe a last place where you stopped off, and then you go down from there. Such a loop can be accomplished via a recursive function or a recursive algorithm that calls itself. That's what a depth first search is. And it can be accomplished if you're looking at an adjacency matrix where the ones in particular refer to edges. You only really have to look at one part of the adjacency matrix, just maybe from the diagonal down or something like that, because it's symmetric, say. And so then when you're looking at this, what you do is you start going down a column, and once you hit something, once you get to a 1, then you remove once you get to a 1 right here, you remove it because you're going to use it. So maybe that's used, you're going to do something with that. And then you go to, so this particular position right here tells me that the next time I search, I go to the column that corresponds to this row. So go to that column, then start going down that one. And once I hit something, then I go to the column that corresponds to that row. And then I start going down that column. Now, as soon as a column is finished, erase that and as soon as a column is finished, get rid of that particular column and row. Make sure that it's that not only is the column gone, but the row is gone that corresponds to it, and that'll eliminate any going through any other column to actually hit it. So eliminate that column and that row, and then go back to the last column that you were going down, and then repeat, and then the last column you're going down, and so forth. And it actually, in that particular way, at least in the adjacency matrix, that's a viewpoint of what's happening. Now, with that being in mind, really you're going to be going through less than the number of entries. You're traversing less than the number of entries in the matrix, which is n squared, if n is the number of vertices. So you could think that a depth first search will have complexity O(n) squared. Okay, now what about breadth? Okay, so for breadth first search, what are we doing? Well, we're going to be traversing the edges. First, we look at a vertex, and we first do everything that's adjacent to this vertex, and then we move on somewhere, and then we do everything that's adjacent to that. We don't use this one. We've already used that. And then we do everything that's adjacent to this one, and then that one, and then we go over here, and we keep on going. But first, we do one level at a time away from that vertex. So here, and then a level of 1 away, and then a level of 2 away. So it's by breadth. So depth goes down deep, and breadth kind of keeps us going at a breadth each time. What would be the complexity? Well, again, let's think about how this happens in the adjacency matrix. Okay, so we have our adjacency matrix, and what we do is we run through a column, checking our edges, we go through the whole column. So before for depth, we go through the column and then we switch up which column each time. And that's like going through depth. But here, just go through the straight column for the edges. But as soon as you finish that column, you eliminate the whole row that corresponded to this column after you do that. And then you go to the next column and you start going down that one. And as soon as you do that, well, in particular, but which next column do? You actually need to do a column that corresponds to one of these ones that you, one of these particular ones that you had before. So maybe to keep information on that. So, so on this one, then you go to that column and you go through it, then you eliminate. So you're not going to hit those particular edges again here or here, because it's a symmetric matrix, and in that column and row will correspond to those ones. And you're just kind of going down column by column. And again, the complexity, since you're just traversing the entries of the adjacency matrix, is again, at least an upper bound would be n squared. So we have O(n) squared again for breadth search. Thanks for watching.